Namaste. Welcome to this channel Chemistry Made Easy by Dr. Ashok Mulik. Today we will see the next point of this topic, ionic bonding, that is Born-Haber cycle. This Born-Haber cycle was first observed by scientist Max Born and Fritz Haber in 1919. In 1919, when he was studying the thermochemical changes taking place in case of formation of ionic solid, that is sodium chloride. So he developed the thermochemical method for the determination of lattice energy for sodium chloride. During this process, he observed that the thermochemical quantities which are known to us are or can be used in order to find out the thermochemical quantities which we want to know. So the unknown thermochemical quantities can be obtained by using the known thermochemical quantities by this method developed by Max Born and Fritz Haber. So during this method he used the Hess's law. Hess's law. It says that Hess's law says that any chemical process which takes place irrespective of any path followed can show or shows the definite change in its enthalpy, or in short we can say enthalpy of a process. Enthalpy of a process may be chemical change remains unchanged, irrespective of its path followed. It means the change in enthalpy of a process, that is chemical process, cannot change when we change the path for the process. It remains the same, and this is the base for this Born-Haber cycle. So on this basis he studied the formation of sodium chloride solid. And proved that the enthalpy change of a chemical process remains constant, and it is possible from such type of studies to find out the unknown thermochemical quantities. So we will see this Born-Haber cycle here. So according to Hess's law, this process, chemical process, we are considering here the formation of sodium chloride, So this process, according to Hess's law, can be carried out in two ways. So we will see here route 1 or method 1. You can see any route 1 or method 1. Route 1. So we will here use direct method. Direct method of formation. What is this direct method? Here we are taking sodium metal in solid state. It is reacted with chlorine gas, Cl2 gas in molecular state, and gives NaCl solid. It gives NaCl solid. So this solid NaCl shows the change in energy, that is change in enthalpy or enthalpy change of the process, as H. This change in enthalpy of the process is called H, and it has negative sign because the overall process shows evolution of energy or loss of energy. That is why this enthalpy has given negative sign. So this is one route, that is route 1, that is direct method. It shows direct conversion of sodium from its solid state and chlorine from its gaseous state to the formation of solid sodium chloride. Then we will see the route 2, route 2, that is indirect or hypothetical steps. Indirect method, or we will say hypothetical steps. So this method route will involve some steps which are explained in this way. So first is sublimation of solid sodium. Sublimation of solid sodium. So this will show that the sodium from its solid state is converted into sodium in its gaseous state. So this is called sublimation. So this is called sublimation. So we say it is sublimation. So this will show requirement of some energy. So sublimation means heating the solid to form its vapor state or vapor phase, that is gaseous state. So it will require some energy, and it is called S, that is sublimation energy. So this process needs some energy, or we are supplying energy for this process. So it is called S plus, that is the sign is positive because energy is added to the system. So this is the first step, that is sublimation of solid. Now second is formation of a cation. So here that sodium which has obtained in gaseous state will lose its electron, and it will produce sodium ion in its gaseous state with the loss of such electron. So this process shows that the sodium atoms are losing electrons, and sodium from its gaseous state are converted into sodium ion in its gaseous state. So this process requires some energy, and that is called first ionization energy. And ionization energy is shown in terms of I, and here I has positive sign because the energy is added to the system. So here the sign is plus. So energy term shows that energy is added to the system in order to produce cation from solid sodium, from gaseous sodium atom. Then the third step is dissociation of chlorine. Dissociation of chlorine. So we know that chlorine exists in the diatomic molecular state, that is, we are presenting it as Cl2 and it is in gaseous state. For this process of sodium chloride formation, we require one chlorine atom per atom of sodium. So we are taking half of this molecule. So this chlorine will require one electron to form its Cl minus ion in gaseous state. First, we are considering dissociation first. So this chlorine on dissociation will produce chlorine atom in gaseous state. So this type of dissociation process also requires some energy, and it is shown as D, and D is positive because energy is required for breaking the bond between two chlorine atoms. So this is shown with positive sign. So here the dissociation of chlorine takes place in this way. Then next step is, that is fourth step is formation of chloride ion. So this process takes place by using the chlorine atom in gaseous state, which gains one electron and gives Cl minus ion in gaseous state. So this is the formation of chloride ion. So this formation of chloride ion takes place with the evolution of energy, and that is called electron affinity, and we represent it with E. The symbol is E and its sign is negative because energy is evolved, that is lost during this process. So up till this fourth step we have obtained Cl minus in gaseous state. Now the fifth step is the formation of sodium chloride lattice. So here we find that the formation of sodium chloride takes place by combination of Na plus, which we have seen formed in earlier steps, that is Na plus in gaseous state, plus Cl minus, that is chloride ion, is formed in also gaseous state. So this on combination gives NaCl in solid state. So here this NaCl also exists in the ionic state. So that is the Na plus and Cl minus. When we see the structure, this NaCl also exists in the Na plus and Cl minus, that is cation and ionic state. So we are showing that this NaCl in solid state. So during this process, the amount of energy change, that is the change in energy, shows that the energy is given out, and we are presenting this with the lattice energy U and with negative sign, indicating that energy is lost during this process. So this is the fifth hypothetical step. Now we will show that the energy change or change in enthalpy is irrespective of the process. So in the root 1 we have seen that there is minus h. So that change in enthalpy is minus h. And in root 2 the net change in enthalpy, we have divided the root 2 in 5 steps. So all these terms which are related to energy are taken together, and we are showing that it is equivalent to this energy change or change in enthalpy according to root 1. So this is the enthalpy change according to root 1, and we are showing the energy terms which are considered in root 2. So this is minus h. Then first term is sublimation energy plus second is ionization energy. Then third is dissociation energy, that is 1/2 d. Then after d we have taken another term, that is the electron affinity, that is minus e, and again another term minus u, that is lattice energy. So it gives us this equation, that is minus h is equal to s plus I plus 1/2 d minus e minus u. So according to this equation we show that all these terms shows that the sum of all these energies is equal to this minus h. So this is the ultimate equation which we have generalized here. So we know, or in this equation we know some quantities which are available in the literature. So using these quantities we can find out the unknown quantities for any ionic solid, or we can hypothetically consider any ionic solid and we can calculate these values using the available values from the literature, and we can show or interpret whether that type of ionic solid does exist in nature or it is just a hypothetical or imaginary. So such type of interpretation can be made using this equation. So the application shows that the calculation of lattice energy, calculation of electron affinity, and study of the hypothetical solids, as we have discussed just now, are the important applications of this Born-Haber cycle. So Born-Haber cycle is important for all such considerations. So we will stop here and continue the next topic in the next lecture. Till then, goodbye. See you next time. So please subscribe to this channel and share this video to your friends, and please press bell icon and like button so that we will bring you next topics and you can be able to complete your studies. Thank you very much.